Hello, what's up everyone? Welcome to the second part of my Swift Data tutorial. Last time we covered in a bit more than 2 hours the basics of Swift Data. So first we saw how to persist simple data on disk so that whenever we relaunch our app, the data that was created hasn't been launched but has been persisted to disk and is still available on the next launch. Then we took a bit more of a detailed look at what we could call the basic features of a framework like Swift Data, which are, in addition to saving and retrieving data, also updating, deleting data, and sharing ownership of data. By that I mean, how do you make it so that a child view can edit some child data? So we covered that, and this time we're going to cover the third and final part of the tutorial, which is about relationships. So how do we manage relationships between our different pieces of data in a way that our data is going to stay consistent and valid across time? So just like last time, we are using a tutorial made by Apple to learn about Swift Data. So if you are watching on YouTube, you have the link to this tutorial in the description of the video. And if you're watching live on X or on LinkedIn and you want to check out the tutorial, just go on YouTube and you will find the link there. I think I've said all I wanted to say for the intro. Just as always, if you're watching live, don't forget that you have a chat and you can make in this chat every remark. You can ask every question that you might have. I will do my best to try and answer it. And don't forget that anything that comes to your mind will probably come to the mind of someone that's watching the replay. And so by asking it live during the chat, you're giving a voice to that person. And that's something that's pretty cool when you think about it. So let's get started. We are on the third part of the tutorial, how to work with relationship and with relationships. And we're going to learn about relationships and queries. We learned a little bit about queries before. We used the @query macro that would allow us to fetch persisted data. So if we said add query, I think it was movies, then we would retrieve all of the persisted movies. I think I'm going to sneeze at some point also. So let's get going. So most apps have multiple types of model data that are related in some way, such as calendars and appointments. In this tutorial, you'll extend the Friends Favorite Movies project from the previous chapter, so the app that we did in the second part of the previous video, to keep track of friends and their favorite movies. Start by building the data model and UI to add friends, then to connect friends and movies. Establish a relationship between the two model types, and update the app to display and edit related data. Finally, add a searchable interface to filter the list of movies by title. And you can see that you can download the files of the project. So if you did the project like me last time, you can just resume from where you were. Personally, I've downloaded the project. This way, if you are just following this part of the tutorial, we have the same thing, and I am sure that what I'm doing matches what you will get. So the project, actually, it's in Xcode. So let me just show it to you very quickly. Let me run it in the simulator, actually, so that we can have a look over the project. Of course, it's going to take a bit of time to build because I haven't built it beforehand. All right. Actually, it was quite fast. Almost there. I don't know why, but launching the app the first time is always the longest. All right, so we have this app where we can add movies. So if you remember last time, I kept adding Dune 2 as a movie. So I'm going to add Dune 2. I'm also going to add Dune 1, I guess. And what was nice was that if we killed the app and relaunched it, the data was persisted. And we could also edit movies. So for instance, if I call it Dune part 2, which is the correct title. When I go back, you can see that the data was updated correctly. So when I go to the child view, I can edit child data. And when I come back, the piece of data that I have edited in the child view has also been updated in the parent view. And that's because the child view and the parent view were both referring to the same piece of data that was updated once and displayed in two places. Actually, let's have a look at the code. So if we look at the model, so we have this type movie. So this is what implements our model, and you can see that a movie is a class. So that's what allows this mechanism of if we update one instance in a view, then all of the other places that use the same instance are also updated. It's because it's a class. Data types are reference types in Swift data. And we saw that there is a good reason for that is because since instances are unique, it allows Swift data to be able to track changes and to refresh the data model accordingly, but also refresh the views that consume these data types accordingly. So the model is declared as a Swift data model thanks to the @model macro. So I'm doing a bit of a recap of what we did last time, basically. And here we have some sample data in the static property, but you can see that if we just abstract over the @model, the way we declare the model is similar to how we would declare data that is parsed from a web service. For instance, we have properties. They are vars here because we allow them to be updated, but they could still be let constant if we didn't want them to be updated. And the only differences are that what would be a struct when decoding data from a web service is here a class, and it's annotated with @model. Then let's see what we have else. So then we have this class called sample data, but sample data is just a way to provide sample data in the preview, and we are building here the Swift data stack, so with the model configuration and the model container. So I won't go in details in how this works because I would just be redoing the previous video. So you can refer to the previous video if you want to learn a bit more about how the Swift data stack works and how you can set it up from scratch. Here you can see a bit of code that's interesting of how to save some sample data. You just do the context, you insert a movie, simple as that, and then you save the context in order to flush basically the cache and make and commit the changes. I might be using the word commit slightly wrong here because commit has a specific meaning when talking about like databases. So the word commit kind of implies that you can roll back. I'm not sure that you can, so it's more about saving. So it's about saving the data in the model and letting the UI know that it needs to be updated. What else do we have? We have the content view. So let's just have a look at the code. So the content view retrieves the model context through the environment. So it's what is going to use in order to interact with the data. We have the @query. The @query is the property wrapper, or is it? So it's a macro. It's a macro, not property wrapper. This one, and you can see that. So here @query, as I was mentioning just before, @query allows us to retrieve data that had been persisted, and we can also apply some kind of like processing. Here we say that we want to sort the data by increasing order of the title of the movie. So for instance, if I go back here, you can see Dune Part 1, Dune Part 2. If I edit this one, and I put like an A just so that it's like at the beginning of the list, you can see that it moved to the top of the list because we are sorting by title, sorted in increasing order. Then we have code here that is more about Swift UI in a way. How do we use the context? We use the context here when we are adding a new movie. So we insert the new piece of data inside the model context. And when we want to delete, we also use the model context for that. And you can see that it's being injected here through this modifier, so model container, which is similar to injecting into the environment. I guess this does a few extra things than just setting the property for a key path that allows you to retrieve the property through the environment, but the idea is kind of similar. And last thing, let's have a look at the movie detail. So it's the view, the detail view. The only thing I want to show you here is that you have a bindable and at bindable for the movie. So at bindable, it's a property wrapper that allows you to be able to make changes to a piece of data and have the change also be taken into account in the parent view that passed you this piece of data. And so that's how you can do things like $movie, for instance. So this is how we share the ownership of the piece of data, so of the movie. And then same thing, we use the context in order. I think we use the context if we do the delete button. And it's in that case, it's when we create a new movie, we first add it even as in an empty state. And when the user cancels, we delete the movie. So that's all for this little tour of what we had done last time. I think now we can focus on what's new, what we're going to do this time. So we're going to create a new data model. So we will create a friend model. So we're going to start by adding a model to the project to represent friends. The process in this section will feel familiar if you've completed the create, update, and delete data tutorial. So what we did in the previous video. Step 1, use your friend favorites movie app project from the previous chapter, or download the project is what I've done, and opened it, I've done it. So now we create a new Swift file called friend. So let's do this. Let's put it next to a movie. So we create a Swift file and we call it friend. And we have our file right here. Now, what do we do inside this file? So we import Swift data and we add an empty model class. There will be an error that we will fix in the next step. You probably remember why we get this error if you followed what we did last time. Then we are going to add some properties. So we'll keep the friend model very simple. We add a name property and an initializer, which is nothing more than a member-wise initializer. Now the project should build correctly. It does. The little toast appeared outside of what you can see, but it did say build succeeded. Actually, no, you can see it right here also. Okay. Then we are going to add an array of sample friends to the friend type. We'll use them later when we integrate the new model into the app. And if you're using your own names, be sure to include at least 5 friends. So we need at least 5 pieces of data. I'm just going to keep the same one than the one that they use. This way it makes it easier if you are following along. So we have 5 pieces of data. Okay. Step 6. In friend favorite movie app, so the entry point of the app, we're going to add our new model to the schema so that Swift data can add it to the data store. So we're going to go into this file right here. And you can see in the schema, we pass an array of types that are modeled according to Swift data. And here we're going to add a new model, so friend.self, like that. And here they explain a bit what the schema is. So the schema of a model helps you. I'm just seeing that I'm hiding the code a bit, so let me move the window a bit. It will be better like that. The schema of a model helps connect the classes you define in your code to the data in the data store. And for now, we need to declare both because they are independent. I think later down the line, once we will have established a relationship between the two types, I think only one will be needed to be declared here, but we'll see if I'm correct or not later. So with this change, we've let Studata know that there are these two types that exist and that it needs to handle. And as we can imagine, this probably gets translated into, for instance, database tables being created or something different, but something somewhere is linking this schema, which is very declarative, into the physical representation of the data once it is saved on disk. So it could be databases table if it's a SQLite database. It could be, for instance, decoding code and encoding code if it's stored in a JSON or a property list. If the data is retrieved through iCloud, it could be just code that parses data from and to iCloud, but this gets turned into something else. Step 7, to make the sample friends available to your previews, go to the sample data file and add friend.self to the schema there as well. So here we can see something. It's the fact that, so we go into sample data, we need to declare the schema in two places. In a real app, here I would really recommend that you store this schema in a single place, in a constant somewhere, because it's so easy to add it somewhere and forget it somewhere else. And I wouldn't recommend having two pieces of schema that live in two separate places in your app. Also, I'm going to split these calls across several lines. This way, I'm sure that I'm not covering them by mistake. Okay. Then, in the insert sample data method, we insert the sample friends into the model context so the names appear in the previews as you work. Recall the sample data class calls this method as part of its initializer. So here, we have another for loop, so similar to this one that inserted the sample data for the movies. Here, same logic, but for the friends. All right. Next step, step 9, create a new compute property to return a sample friend. You'll use this when you create a detailed view to edit friends. So once again, same approach then for the movie. We just return the first one in the array of sample data like this. Okay, section 2 now. We're going to display a list of friends. So in this section, you'll build a friend list view to display a list of friends. You'll write similar code to the existing content view for movies using friend as the model type. In apps with more than one model type, you'll sometimes code multiple views that follow the same pattern. Feel free to refer to content view as you code. This, of course, means that in a real app, you might want also to factorize code in order to not re-implement the same thing multiple times. But be careful when you factor code like this, because it's so very easy to do things like very complex, like using inheritance or things like that. Actually, not inheritance because you can do it in SwiftUI, but when you have several views and you want to factor them into a single view, what I meant to say is that sometimes what you end up with is actually more complex to maintain than just having 2 or 3 different views that share similar code. So be careful about that one. So now we create a new SwiftUI view called friend list. So let's go into Xcode. We're going to create, no, I don't want to create a new project, just a new file. I did the wrong shortcut. So this time we create a new SwiftUI view and we call it friend list. So we have our new file. What do we do inside? We're going to replace the contents of the body with a navigation split view, leave the sidebar empty for now, and include a default detailed view that prompts people to select a friend if none is selected. So just like we did last time. The navigation split view uses its sidebar as the root of the navigation hierarchy, so you won't see anything in the preview yet. You'll add a list of friends to the sidebar later. So let me make this code here. And what I'll do is that I'm going to do just like last time. For the preview, I will put an iPad because the split view, it's really meant to add a better UX on iPad. So why not show an iPad actually? And you need to put the iPad in landscape like that. I will put it on dark mode also This way it's a little bit less violent on the eye. Would have been nice if I could have used an iPad mini actually. I think because there is more room. Yes, I can do iPad mini. Okay, let's see. It's reloading, but iPad mini is a bit smaller, so this way the text will appear a little bit bigger. So while it loads, let's go back to the next step. So next step, step 3, we import Swift data. So let's do that. Yeah, the iPad mini might be a tad better. So import Swift data. Above the body property, we add the environment, query, and state properties. We'll need to manage a list of data models. And at the bottom of the file, set up a model container for the preview. So very similar to what we did last time. So here I add all of this, okay. Let me hide the preview for now because we don't need it. So the model context in order to interact with the data that's being persisted, the query to retrieve the data that's been persisted, and the state to be able to create a new friend similar to what we did last time. And in the preview, we're going to add the model container, so like this. Perfect. So we'll need the model context from the environment to add and delete friends and the friends query to populate the list. So what I was explaining, when someone wants to add a new friend, you'll display a sheet to collect the new friend's information by assigning a new instance of friend to new friend. So very similar to what we did last time. Then we implement an add friend method to create an instance of friend, and we add it to the model context. So let me add this method. So add friend, we create a new friend, we insert it, and we set it as a new friend, which later down the line, we're going to implement a mechanism so that we can display modally a view with a form to be able to set the data of the new friend. So here we're doing the same thing than what we did last time. Step 5, we implement the delete friends method to remove items in the friend query. Like the method to delete movies, this method works with an index set that specifies which items to delete, and an item set is also what SwiftUI returns to you when you implement the modifiers to delete data. So then, step 6, in the sidebar of the navigation split view, we're going to add a group with an if-else statement to display different content based on the state of the friends query. Leave the if clause blank for now. Use a content unavailable view in the else clause so people don't see a blank screen when they first launch the app. Recall that the group lets you apply modifiers to the if-else statement inside. You'll use it to display a title and a toolbar later. So if we add a modifier on the group, it gets distributed on the views inside the if-else. It's not really distributed. It's that whatever the modifier does is applied and then will be available to the views inside the if-else. So it's like the code is not moving. It's just being called earlier on. So I need to copy the group right here. Actually, you know what? At this point, let's have a look at the preview. Always good to see what it looks like. Normally, I should be able to see something here in the content unavailable. Why don't I see anything? Let me see. Just want to make sure that I'm not missing anything. No. It's indeed empty. What could be happening here? I was expected here to have, like, on the left, the no friends that would be like in the... Oh, I guess no, because there are friends. There are friends, but we just don't display them. That's why. But they are friends because we inserted them in the sample data. So that's why. Here we need to actually display the friends that do exist. So we are in the if right now. No, not in the else. So that makes sense. Step 7 is that actually, in the if clause, we add a list with an empty for each that iterates over the friends property, and we use the onDelete modifier to handle item deletion with the delete friends method we just wrote before. So let's add this. Okay. Now we have this list. We just need to actually display something for each friend, like a text with the friend's name, for instance. So in the for each view, we add a navigation link. Since there's no friend detail view yet, we just display the friend's name for both its destination and the label. So let me add the navigation link like that. Okay, now we can see the friends are appearing in the list. Okay, that looks pretty good. I'm just going to put it back in light mode because like I've seen before that when you're in dark mode, sometimes video compression isn't great and the text is harder to read. So I'm going to put it back in light mode. Hopefully it will be a little bit crispier, especially when you're watching live. And here we have an experiment. Check the list of sample friends appear in the preview. Selecting one of the friends should take you to a new view with that friend's name in the center. So it's actually what I was doing just before. So indeed, it's working as it should. Step 9 is to add a navigation title to the group to display a title above the list. So let's do it. So we're doing more of a Swift UI thing than of a Swift data thing for now. So we have added the title right here. Step 10, we use the toolbar modifier to place a button in the navigation bar that adds a new friend. So just like we did last time, okay. So now we have the plus button that was added. You can see it adds new friends, except that their names are empty. Then we're going to add also an edit button to the toolbar to give people an easily discoverable way to delete friends, because right now they can do the swipe to delete, but it's not super discoverable. So we're going to add also an edit button like that. Now we have the edit button, which puts the list in edition mode, where it's easier to remove data. Okay. Then step 12, we use a sheet to handle adding new friends. Because you don't have yet a view to edit the data of a friend, display the new friend for now. So we're going to add a sheet. So as I was saying, it's a way to display a view modally. So now when we have something in the property new friend, we will show just the text, but you can see that we display this. And for now, there is no way to dismiss it actually. So we are stuck for now, but we're going to improve, of course. So to try the sheet, click on the add button to add a new friend. That's what I did. And once you've presented the sheet in the preview, you won't be able to dismiss it. To see the list again, reset the preview by choosing editor, canvas, refresh canvas. Interesting. First time I do this. So canvas and then reset canvas. Oh, so you can do that. That's kind of nice. I did not know this shortcut. So good to have learned it. All right. Section 3, create a friend detail view. So very similar once again to the movie detail view we did before. I see in the chat a few people have joined. Welcome, I hope you're enjoying this tutorial, which is about Swift data, but also a bit about Swift UI. Because this tutorial, it's part of a larger set of tutorials from Apple in order to teach people how to get started with developing for iOS. And actually the Apple ecosystem in global, because there is also a part about Vision Pro. So that's why it's a bit more general than just Swift data. But it's kind of nice because this way it makes it as a very like well-rounded tutorial. And in the future, I will also cover the part about how to get started with iOS itself. It will be interesting for the following weeks. So let's resume section 3, create a friend detail view. So we're going to create a detail view to edit friends that borrows the design of movie detail. If you want, you can try creating friend detail on your own, practicing the techniques you learn in create, update, and delete data, so the previous chapter. Whether you do that or follow the steps in this section, you can refer to the movie detail view as you code. So if you're watching a replay and you follow the previous video, actually, I would recommend that you try to do this by yourself, because I think it's a very good exercise and it should be really the same approach. So it's a great way to make sure that you've really understood what's happening here. How do you build this view? How do you share data ownership between the parent and child view? So it's a great exercise. And I see, thank you for the kind words. So I hope I pronounce your name correctly. It's iOS Dalu World. I hope I pronounced it correctly. So step 1, we create a new SwiftUI view file named friend detail. So let me go back to Xcode. So we have friend list like that. I'm going to try and organize data a bit, the files a bit. So I'm creating the friend detail. Okay, so we have movie detail, friend detail. There is a little bit of structure. Not perfect, but there is something. Step 2, so we create a bindable property for the friend and we add the necessary environment properties. So very similar to what we had done in the movie detail view. So like that, all right? Making friend a add bindable property lets you pass it into controls like text fields. You need the model context to delete a friend when cancelling and the dismiss action to dismiss the detail view when it's presented modally. And we will fix the error message in the next step, error message, which is that missing argument. Yes, we don't provide a friend to create the view, but you need to provide one. Okay. Next step is to fix the missing argument error by passing a sample friend to friend detail in the preview, then nest it in navigation stack and connect it to the shared sample data instance. You'll need a navigation stack in the preview to see the toolbar items you will add later. So let's paste in the code in the preview and let's show the preview. This time let's go back to an iPhone 15 for the preview. That should be more than enough. Oh, and I need to import Swift data, otherwise I don't have access to the modifier model container. Should be better now. I'm gonna split this call across several lines. I'm wondering, yeah, like this should not have been added. I think that's what was causing issues. Like, yeah, there was no reason to have these extra parentheses. Okay. So we have something appearing. Now let's keep building. So next step is to add an isNew property and create a custom initializer whose isNew parameter has a default value of false. And if you remember from last time, this is what enables us to use the same view both when creating a new piece of data, but also when editing an existing piece of data. Okay. Next step, we create a second preview to display the new friend version of the detail view. So we are dealing with the two modes of the view, and this way we can easily preview them in two dedicated preview. So you're setting the new preview to display its navigation title inline. You'll see why when you add the navigation title for friends detail in a few steps. So here. And if you've seen the previous tutorial, previous video, you probably remember why we do this. Then we're going to replace the text in the view's body, so the hello world, with a form containing a text field to edit the friend's name. We disable autocorrection to avoid issues with less common names. Actually, if I go to sample data, you can see that in Xcode I have enabled in friend in Xcode I have enabled spell checking, and you can see that one name which isn't in the dictionary gets treated as a spelling error. You can see it's underlined in red. So kind of nice to see this. And if you're wondering how I enable spell checking in Xcode, it's actually going to be the topic of tomorrow's video. So you will have the detailed tutorial tomorrow on how to enable this feature in Xcode, which is very useful, but also by default disabled for some reason. So we are in friend detail, so I'm going back to friend detail, and I need to update the body here to put a form. So let me put form. Let me also go back to an iPhone. That will be much better. All right. Yes. Okay, so we have a form now. That's better. Also going to add the missing new line. Okay. Step 7, we add the navigation title with appropriate language for both uses of the view, adding a friend and editing an existing one. So let's do that. We can see it's being displayed here as inline in the case of a new friend, and as a large title, which is the default in the case of a friend detail. And after you complete friend detail, you'll present it in a sheet for the new friend interface. Because sheets automatically present navigation titles in line, you specify this behavior in the second preview to represent how the view will look in use. Experiment. Try using the buttons at the top of the canvas to see how each preview renders the title differently. So what I showed you just before. Okay. Step 8, we add a toolbar modifier to disable the toolbar when displaying the detail view. To edit an existing friend, we add an if statement that checks the isNew property. Because the toolbar has no items, you won't see anything in the preview yet. So when the toolbar is empty, it does nothing. It doesn't add an empty toolbar, which kind of makes sense because it simplifies how your code looks like. If you wanted to have an empty toolbar displayed, you could always do it, by, I guess, by putting like maybe not an empty view, maybe either an empty view or just like a group that is empty, and this way maybe you would get something. Let's see. Actually, you know what? I'm going to comment this out because I want to see like if the preview like changes. Yeah, so indeed nothing changed, and it would have appeared around here if there had been something. Okay, step 9, we add a done button to the toolbar that dismisses the view. To see the button, make sure you select the new friend preview. So why that? Because here, if I add the view, you can see it hasn't appeared, but it makes sense because here we are in a navigation stack, so there is a room to display the toolbar, but isNew is set to false because it's the value false by default here, and we haven't provided true in this preview. In the other one, we have provided true. Actually, I'm going to split the code across several lines. You can see here. So when I go to new friend, you can see that we have the done button here. And we dismiss, but in the preview, it's not presented, so dismiss does nothing. So that makes sense. Step 10, we add a cancel button to the toolbar that deletes the friend from the context and dismisses the view. So we add the cancel button also. So something like that. Okay, we can see the cancel button has been added. Actually, let me make the preview slightly bigger so that you can see it better. So when someone taps the add button, so the plus in friend list, you create a new friend and insert it into the context, then present the friend detail view in a sheet. If they decide to cancel adding a new friend, you need to delete it. So we saw last time that it's not the best pattern because you can see the empty piece of data being added, but for a simple tutorial, it does the job quite elegantly. So step 11, we go back to friend list and we use our finished friend detail view in both places. You'll want to edit a friend, the navigation list to edit an existing friend, and the sheet modifier to create a new friend. And then we try out the features that we have added. So navigation link here. So let me hide the preview so we can see a bit more things. So here we add this friend detail, so like that, and the other place is inside the sheet, so right here, like that. And so now, if I launch the app back into the simulator, we should be able to add a new friend. Actually, no, because we still need to display the view somehow. We don't have a way to display the friends view. But I guess this was going to come next, so let's just keep moving. Yes. So section 4 is about unifying the interface with tabs. So once again, the part that is a bit more about SwiftUI than Swift Data. So you have two parallel interfaces to view and edit friends and movies. But so far, you can't use them in one unified app. In this section, you'll add a tab view to combine the interfaces. Tab views are a great way to let people quickly switch between a small number of related activities in your app. You'll start by renaming content view to movies list, then you'll make a new content view that contains the tabs. So open the content view file, click in the content view struct name, then choose editor, refactor, rename to change content view to movie list. So let me copy that. including in the code command near the top of the file. So I go back to Xcode, I go into the file content view rather. So content view. I do right click on the content view, refactor or rename, and then I rename it to movie list everywhere. Okay. I do rename. And it didn't do it here. Maybe I should have clicked on the... Maybe there was a little plus icon somewhere that I missed, like last time, to do this part of the rename, but I just did it manually. Okay, what comes next? Then we create a new SwiftUI file named content view. So we add another content view. So I'm going to move movie list next to friend list. Actually, I will do like movie list, movie. So movie list, movie, and movie detail. And here, friend list, friend, and friend detail. And you know what? I'm going to put this into a... I did Command G to create a group. It wasn't that at all. So I wanted to do new group from selection and to call it this one movie and to call this one friend. Just that we put a tiny bit of structure because we're starting to have a good number of file. So we create now a content view. So let's do that. So Command N, new SwiftUI view. It's called content view. All right, what do I put in this file? So we're going to pass the sample data container to the preview so that we can see movies and friends inside the tabs. Remember, you also need to import Swift data so that you have access to the modifier model container. Then we're going to use a tab view to display the movie list. And we use a tab item modifier to provide a label for the tab view to display for each of its child views. So this is more of a SwiftUI tutorial here. We're using the tab view, so a way to provide a way to navigate with several tabs accessible on the root view. It's a very common pattern. Most Apple apps use it. Think about the music apps, the TV apps, the clock app. They almost all of them use this pattern, which has been around since the beginning of iOS, actually. All right. Now we're going to add a second tab to display the friends list. So yeah, we add a second view inside the tab view like that. So movie list and friends list. And one more thing, in the friends favorite movies app, so the root, the entry point of the app, we change movie list back to content view to use it as the root view. So inside this file here, so the content view was changed to a movie list when we did the rename, but we put it back as content view, but it's a new content view now. And if I launch the app in the simulator, let's see how it looks like right now. So you can see you have the two tabs, movie and friends. And it's interestingly, so we have the movies here, but we have no friends. That's quite interesting. Why don't we have some friends being added by default? I guess because the sample data is only used in the previews, and in the app itself, the sample data isn't used. Yeah, it's true. Here, I wrote this data myself. So if I want to add a friend, I'm going to add just like myself, for instance. If you want to be added as a friend, let me know in the chat, and I will also add your pseudo, as a friend here in the app. So now there is data that's being saved thanks to Swift data. Okay. What do they tell us next? Okay, so they tell us to actually add a relationship. So we're getting into the meat of the topic. So now that we have an app that handles both types of data independently, it's time to link them together to make friends' favorite movies live up to its name. Swift data creates relationships by finding properties in model types that refer to other model types. You'll start in your data model adding new properties to relate one to the other. So step 1, in friend, we add a favorite movie property of type optional movie. Recall that question mark denotes an optional type. This property creates a relationship between the friend model and the movie model. By making the property optional, you're making it so friends don't need to have a favorite movie. And in a note, the relationship from friends to movie is called many to one. Many friends can choose the same favorite movie, although any particular friend can only have one favorite movie. And it's a terminology you will see a lot when dealing with relationships in frameworks like Swift Data. Relationships can be either many to one or many to many. They can also be one-to-one, actually. They can be one-to-one, one-to-many to one, and many to many. And basically, the one is usually represented in code as a single property that could be optional or not, and the many is represented as a collection, often an array. For instance, a movie could have an array of all of the friends that have this movie as their favorite, and the question is, how do you make sure that you only define the data once and then it's accessible everywhere? So if you set that this friend has this movie as its favorite, how do you make sure that from the movie you can get back the information that the friends is among people who has this movie in there that should be in the array of people who have this movie as their favorite? And that's typically what frameworks like Swift Data are very useful, because they take care of handling this data consistency for us. So let's add in the friend file. So friend like this. I see someone in the chat is already making their suggestions for movies. All right. So let's add the property favorite movie. Okay. Step 2, in movie, this time we create a property for the inverse relationship back to friend named favorited by. The type of this property is an array because multiple friends can have the same favorite movie. So this time we go into movie and we add the inverse relationship. Note that for now, I don't think we've told Swift Data that this here is the inverse of this right here. I guess we're going to need to do something a bit special in order to declare that. And I think that's the question that you're asking, Amir. Does the model macro add special code regarding the favorite movie for relationship? We'll have a look by expanding the macro. Let's see what the tutorial says after, but it's a very good question. How is this relationship managed under the hood? So what do they say here? They say that the friend favorite movie and movie favorited by properties form a two-way relationship. In the direction from movie to friend, it's a one-to-many relationship. One movie can be favorited by multiple friends. You can create the appropriate type of relationship by choosing between an array or a single value for each property. So actually, what I was saying just before, enabling you to create one-to-one, one-to-many, and many-to-many relationships. Note, the friend, so this syntax here, create an empty array. To split it out fully, you can just write it like this. So this is more about knowing about Swift rather than Swift Data. So they don't mention about any other code to establish the relationship. That's interesting because I would have guessed that for this one, you don't need to say anything, but here, I guess you need to say that it's the inverse of this one, because I mean, I guess since there is only one relationship of type movie, one property of type movie inside a friend, it can be inferred. But if there were like favorite movie and disliked movie, then how do you know which one is the inverse of the other? So actually, let's expand this macro to see what. No, not create a code snippet. Expand the macro. So right-click, expand. So you can see persist property, another macro. And here, so you can see we have the backing data, favorite movie, okay. So here, it's interesting. If I compare to the one above, you can see that we seem to have the exact same thing. We seem to have the exact same thing, which kind of makes sense because here we are just storing a reference. It's in the inverse part that there is some extra logic. Will the live be available later? Yes, as always, the live is recorded. A replay will be available with the exact same link. So if you're watching on Twitter or LinkedIn, the replay will be available there. If you're watching on YouTube, same thing. It will be available there with the same link then for the live. So don't worry, replay will be available as soon as the live is over. And so let's see on the movie part. If I expand the macro, I want to see what it does for this property right here. So for now, it doesn't seem to do anything special, but because we haven't said that it's the inverse of something else, so I think that's why. So we will redo this once we will have done actually said that it's an inverse property, because I'm sure we need to do something extra here. So in sample data, for the next step, we establish some relationships between the sample friends and movies. So how do we do that? We just set the property of the sample favorite movies. No, we set the property favorite movies of the friend in the sample data. Okay, so in this file right here, just like that. So it's your typical Swift code that you could write with any kind of Swift struct or class. And then what do they tell us? You create relationships after inserting all models into the context. So you need to have first inserted the model and then you create the relationship. Otherwise, if you were to set here a favorite movie that isn't yet inserted, you would probably get an error because you're trying to set something that is not yet part of the Swift data universe. So Swift data doesn't understand what you're trying to set, so you'll probably get an error. I don't know if you will get a crash or not, but you would definitely get either an error, something that doesn't work, or maybe a crash. And in the note, when you set the value of a property at one end of a relationship, so here favorite movie, Swift data automatically updates the corresponding property on the other hand, favorited by for you. You can choose which of the two properties to set. So that's pretty amazing when you think about it, because it figured out automatically that this is the inverse property. So that's quite impressive actually. We'll see if we learn more about it in the next section, which is about using a picker to edit a many-to-one relationship. So how do you build a UI that lets you do what we've done here in this code? But in this code, everything is hard-coded. We want to have a UI so the user can do the thing in a way where they can interact with the data through an app, which is better than just writing something through a command line. So now that your data models are related, you'll add an interface for people to choose a favorite movie. Pickers are a great choice for this kind of task. Swift UI can render pickers in different styles. For instance, in iOS, a picker can appear as a pop-up menu, a group of buttons, or a separate view pushed onto the navigation stack. I see a question, how does Swift data know? I think, and it's only an hypothesis, but since friend has a single property of type movie and movie as a single property of type array of friend, it's possible to deterministically guess which is the inverse of which. Now, there is a way to conduct an experiment, which is to say, we are going to duplicate the property favorite movie, and we're going to call it disliked movie. Let's see what happens. The project still builds, and now I'm curious, like, what this would look like. So you know what? I'm not going to run this code because I don't want to break everything. Maybe they will tell us to do like something extra later, but we will do this experiment later because I want to see what happens when it's not possible to know which property is the inverse automatically. So step 1, in friend detail, we add a picker to choose the friend's favorite movie. So we use a picker, which is a built-in SwiftUI view, when you want people to choose an item from a list of options. SwiftUI applies different styles depending on context. You can also explicitly set the style of a picker using the picker style modifier. So in the form in friend detail, we add a picker. So where is friend detail? It's here. I missed it, so I'm just going to open it like that. Friend detail, and in the form, we add a picker like that. Let's see what it looks like in the preview so that we can have an idea of what we are building. So like that, okay. And then here we have, so the favorite movie here, but we can't tap on it yet because I guess we haven't, yeah, we've put the selection, but we haven't put a way to actually display choices inside the picker. So I guess that's going to be the next part. No, not yet actually. To show the list of movies to choose from, you can use a query just as you do in movie. Oh yes, before we display the list of movies, we need to retrieve the list of movies. So to show the list of movies to choose from, you can use a query just as you do in movie list. We import Swift data and then add an add query property to the view to fetch the movies from the data store, which is the same in both cases. So Swift data was actually already imported. So we can add the add query property, so movies. Okay, and now we're going to be able to use the array of movie here to populate the picker. So we use a for each view in the picker to display each movie's title. The picker might not be displaying the correct value for your sample data. Try using it. You'll notice that you can see the list of movies, but you can't change the selection. Probably this has something to do with the add bindable here. We'll see if that's the reason why. So we pass the data. So now we can choose, but you can see that when we change, actually the change is not taken, the new value isn't taken into account. So let's see. For the picker to correctly display and assign a new value to its selection, so the $friend.favorite movie binding, you must tag each item with a compatible value. Use the tag modifier to associate each movie with its picker item. So the idea is that the picker actually is not displaying the movies, but the movie title. And we need to say, okay, this text which displays this title, to which piece of data does it correspond to? And you do that through the tag modifier, which allows you to say, okay, the tag is the actual movie. So the movie here being the Swift data instance, or rather the instance of data managed by Swift data. It still doesn't work, so I guess we're still missing something. So they say you still can't see the correct value or change the selection because the type of favorite movie is movie optional movie, while the type of movie in the for each is movie. So there is still an inconsistency in the type because one is an optional, the other one is non-optional. And I guess for Swift data, it's a problem. It's still two different types. So to ensure SwiftUI can match the selection, so it's more actually a SwiftUI problem than a Swift data problem, it seems. But to ensure SwiftUI can match the selection type and the tags, use the as keyword to statically cast the movie value as the correct optional type movie ? So we are saying here, we know it's a movie, but indulge us and treat it as an optional movie. This way the types will be the same. And so they say, now try the picker again to verify that it works correctly. So let's try that. So let's change. We can change the movie correctly. Perfect. That's amazing. That's amazing. All right. And someone had given their name inside the chat. I'm going to try and see if I can. I can't copy the name of the. I can't copy the copy paste, but I will do it because you added yourself. You made the effort, so I will do it, of course. So I'm adding this person, which has a friend name. It's Julien, and the movie was Limitless. And I still remember seeing this movie, which is quite, I mean, obviously it's quite old. It's 10 years old, a bit more. I think I saw it in 2011, so 13 years old. This movie gave me one hell of a headache, actually. Like the visual effects when it takes like the cognitive enhancing drug gave me quite a headache. I don't think I've ever had a similar headache when watching a movie, and I have also a friend who had the same experience. So that's why I still remember this movie even a few years after. And now, if I go back, so to where was I? I was in movie detail, I guess. No, in front detail. Yes, I was in front detail. And now, so the friend, let me return. So it was 0. Actually, I want the last one. So I'm going to do last like that. And so normally, we should see Julien appear, and we can set its favorite movie to being limitless. Thank you for participating. And Amir, so your favorite movie is Amélie. I guess it's so Amélie Poulain, the French movie, I guess, which is even older than that because that one is from around like 2001. So if we have another chance, I will also add your name to the data. But in the meantime, let's resume so that we can carry on with the actual tutorial, because I'm experimenting left and right, but I still need to get us to the end of this tutorial. So to enable a friend to have no favorite movie, we need to add another choice to the picker, so to be able to say there is no movie, because indeed we can pick a movie, but we can also say that there is no movie because the favorite movie property is optional. So how do we do that? We add an explicit option, so outside of the for each, which is none, and we also tag it as nil this time. So we're going to add this right here, like that. And so now we have also none as an option. So it's kind of interesting to see that this is how you set a none option. That's quite good to know, because if you don't know how to do it, you might be tempted to add an extra button or something like that. But actually, this is quite an elegant way to do it. Can you explain the tag thing again? Yes. So tag can feel definitely a bit magic. Tag. Let's see actually what the documentation has to say for it. It says that set the unique tag value of this view. It can be anything as long as it's hashable. I want to make sure that we can read everything. Okay, so here we can read everything. So you use this modifier to differentiate among certain selectable views, like the possible values of a picker or the tabs of a tab view. Tags values can be of any type that conforms to the hashable protocol. So the idea is that when you show a picker, usually, you won't show the full object. You're going to show some of its properties. Maybe you will only show the title. Maybe you will show an image and the title, but you won't show the object itself. So the problem that you have is, how do you reconciliate the user tapping on something that displays a subset, a formatted subset of the properties of the object, with the object itself? And the way you do it is by setting the object itself as the tag. So you can see it in a way. You can see it as, here in the picker, in the for each, you display what the user will see graphically in the UI when they select, but the tag allows you to say what's the technical object under the hood that they are actually selecting. And here in this simple example, what they choose is the title of the movie, but what they're actually selecting under the hood is the movie instance managed by SwiftData that will be set for the property favorite movie of the friend instance. So I hope that it makes it a little bit clearer. And yeah, tag is a bit similar to ID. Indeed, they have this same idea of like you pass in a value and then it's handled in a bit of like an auto magical way by SwiftUI. But that's indeed how it works. And it's indeed a bit auto magical because, as you can see here, if you don't have the exact same type, it's not considered. And even if it's like T an optional of T, you need to make it an optional. So it can often happen that when you use a tag, it won't work out of the blue, and often it's because of questions like that where you didn't use the correct type because one was optional and one wasn't. It's something that is very common. And I'm looking at the messages in the chat. So yeah, tag is like the ID, but for display object, yes. And also later for the tab view, it will be much more clear with the example, yes. And in my SwiftUI videos, in my course to learn SwiftUI, which you also have on my YouTube channel, there is a part that talks about like the tab, how to set up a tab view, and I think I get stuck for 10 minutes because of this like not having set things as an optional mistake. So it's very easy to get trapped by this mistake in SwiftUI. And it's one of the parts where SwiftUI, they chose to use this pattern, I think, because it's very like easy to use and it's very convenient. But usually convenience often comes with a lack of built-in safety, in the sense that here, if I forget to do the cast, the compiler won't let me know that something is wrong, because the compiler cannot know that the value passed here is the same than the one that will be consumed there, because the link between declaring the picker and what's inside the picker doesn't exist. And you could, of course, implement it, but then you would need to add extra code when calling the picker to say, for instance, what's the type of the selection or things like that, and it would add some extra complexity. So always interesting to see that every choice that leads to simplicity will always have some consequences on other things. Like everything is a trade-off, as always in computer science. All right, let's go back to the actual topic. So we did this part. And now section 7, use a list to display the one-to-many relationship, so the reciprocal of the relationship. So just as you show favorite movies in the friend detail view, you should also show the friends that are related to a given movie in the movie detail view. Because a movie can have many friends who favorited it, you'll use a for each to display them, because they are an array and not just a single optional value. So in movie detail, you add a third item to the form to display all the friends who have favorited the movie. So we're going to add a section in the form and then favorited by and a for each. So let's go into movie detail. Let's actually open it like that. And so in the form, we add the section and then favorited by, and we can see the name appearing, which is pretty cool. So it does show that the inverse relationship does work without any kind of configuration, which is pretty amazing when you think about it. Okay, so here they tell us you use a section which is a built-in SwiftUI view that you use mostly inside forms to visually separate logical groups of items. So like this here, it brings structure to what's being displayed. And the user knows that these values, they correspond to the people who have favorited the movie. And you can also use sections in list and pickers. So now, step 2, you wrap the section in an if statement so that it only appears if the movie has been favorited by at least one friend. So let's do that. So we're just going to copy paste the if here, and then we select the section, and you can just open a curly brace, and that's it. You've done the refactoring. You can test this code by switching to movie list, then choosing a movie that no friends have favorited. So actually, let me open the app also. It's also a possibility. So I'm going to open the app. And if I go to the movie list, and you can see, so here there is nothing displayed, and there is no else clause, so nothing is displayed. And we don't have an empty favorited by section, which is probably better. Let me reduce this. Next step is that if the list has more than one friend, you may have noticed that their order changes from time to time as you edit your code. To fix this, you'll sort the favorited by array. Start by adding a compute property to your view. For now, make it return the unaltered array for the movie. So we add a property that we call sorted friends. So we are still in movie detail. Let me resume the preview. So we add a property. Where do we put it? We put it after the init. So like that. So for now, it just returns the favorited by array. And I guess we're going to use it here instead of movie favorited by. Let's see what it tells us to do. I haven't read this. So, though you express relationships as array of related models, you shouldn't rely on them to have a stable order. If you did core data back in, I was about to say back in the days, but core data is still around and you can still use it. But in core data, for the reciprocal, the inverse relationships or the many relationships, you wouldn't use an array, but rather an NS ordered set. And the fact there was like the set word kind of conveyed a bit more the fact that you cannot rely on the order of the array to be stable over time. Here, it's a little bit more of a gotcha, and I guess that's why they show it to you in explicitly in the tutorial. So let's see. So then, in the for each view, you replace your reference by the favorited by property with the new compute property. There's no change in behavior yet. Next, you'll add a sort operation to the compute property. So let's do this little change, which is quite easy to do. We'll replace this here and this right here. All right. And yes, very good remark. Swift data actually uses core data under the hood. Yes, I read about that. I haven't confirmed it myself, but I've read a lot about that, and that makes sense. But it's the same logic than it's a very good remark, and it's the same logic than Swift UI that uses UIKit under the hood. It uses it less and less over the years and over the new versions of iOS, but indeed, just like Swift UI originally was a declarative layer around many UIKit components, the same way Swift Data is a declarative layer around core data. One of the advantages of this is that I believe it makes the interoperability between core data and Swift data easier to achieve than if they were two completely separate frameworks. And also, there are many places where Swift actually builds upon Objective-C under the hood or uses features from Objective-C under the hood. So, in the end, everything is assembly code and everything is zero and ones. So you keep building higher abstractions, but that doesn't mean that you need to discard all of your older abstractions. You can just build something that wraps the other abstraction. What's always interesting to consider is that I'm sure that just as much as Swift Data feels like a state of the art right now, back when core data was first announced, it was probably also felt as being like a state of the art and having like all of the nice and shiny new features that more than 10 years ago were state of the art. Like using core data was probably better than using whatever you had back then in the Java world. Even though I wasn't there back then, so I'm just making an hypothesis. Don't take my word for it on this one. All right. What do we do next? It was in 2023, yes, for Swift Data. It was announced last year at WWDC. And so actually, I realized I haven't mentioned it up until now, but Swift Data is only iOS 17, of course. You can't use it before iOS 17. So if your app still has to support iOS 16 or even older versions, the answer to can you use Swift Data is just a big no. But keep in mind that iOS 18 will be coming out soon. So that means that apps that will support iOS 17 and 18 will be more and more common. So that's something to keep in mind. If you're starting a new project, when you start a new project and you are thinking about which version of iOS should I support, you want to think not about the moment where you start the project, but the moment when you plan to release the first version. And for long projects that can take maybe like a year to develop, it can make quite a difference. But yeah, Swift Data is actually quite new. And I think for its first version, it did a better job than the first version of Swift UI, which was basically more of a public beta than something really like production already. Even though I've seen some people share like tricky bugs about Swift Data. So if you were to use it for a big project, do your homework a bit. Try to read about the issues that people are reporting just to make sure that if it still makes sense for you or not. Okay, so now implement this sorting. So in the complete property, sorted friends, we're going to actually sort the data. So following the movie.favorited by, we start typing sorted from the code completion. Then we are going to choose sorted by and insert it into the code base. Okay. That's quite a convoluted way of saying people to do things, but okay. So I guess I'm just going to copy and paste so I make sure that I don't do something different. So here, like that. And of course, I will need to replace this code right here with something. And here we have two friends. But no, it will be like a left-hand side and a right-hand side. So this code is not finished. Okay, they really explain like how sorting works. So this method, so sort on array, is similar to remove all, which we saw in which you can see in a previous part of the tutorial, which I don't think we have covered. And so you provide a closure to sort it by, and it uses it to sort the array of friends by comparing two items at a time, or rather by comparing items two at a time. The closure has two friends parameters representing two of the items in the array, and you return true if the first item comes before the second, and false otherwise. So the actual code looks like this. So first and second, left-hand side and right-hand side. And this just says, how do you know the order of two friends? Well, you take the same order than their name property. It says that, nothing more, nothing less. And now the list is stable, both in the preview and in the simulator. And it's true that, yeah, so not a predicate, but yeah, to have something similar to a predicate, but for sorting, indeed. That makes a lot of sense. Not a predicate, because a predicate, it's a function that returns a Boolean. So actually, I mean, I see why you use the word predicate, because this also returns a Boolean, but yes, it's more of a sort descriptor in the sense that usually a predicate, you don't really use it the same way than a sort descriptor. But I agree that the two things are actually very, very common. And I was about to say like, it's not a predicate, but no, like a sort descriptor is a predicate with two variables. So actually, yeah, a sort descriptor is a special kind of predicate, but it's still a predicate. It's just that, as you mentioned, in the Objective-C world, we had the NS predicate and NS sort descriptor, because I guess the reason is because when you want to describe a sort, then you have the question of how do I sort over several properties? How do I sort in ascending or decreasing order? So there is some like specialties around it. So a sort descriptor, actually, it's a predicate with extra information on whether we do things in ascending or descending, even though that can be implemented by the if you do it like this or like that. So actually, a sort descriptor, it's more like a predicate that can be easily combined with other sort descriptors in order to do things complex, like we sort by ascending name and then decreasing age if two names are the same. But thank you for mentioning the sort descriptor, which is the name that you can often find when you look for code that try to like make how you sort array more generic. And I hope we will see predicates to conclude, because it would be a great way to conclude this tutorial. And so section 8 is actually how to use a custom query to filter movies. So I hope this is where we will see a predicate. So if there are a lot of movies, people might want to search for specific titles. To enable this, you'll update movie list to customize its movies query based on dynamic value. So let's do that. So we're going to add an initializer to movie list with a parameter for the text to filter the query. So how are we going to do that? We add in movie list an init with a title filter. Okay, so we go into a movie list and we add the init with this value that we don't do anything with yet, but it's gonna come, don't worry. So by providing a default value, you avoid having to fix all your existing calls to the movie list initializer. You can use a custom view initializer when you need extra control over how special properties such as queries are set up when the view is created. Okay. We get to it. Step 2, create a predicate that operates on movies. For now, make it return a true value. You'll change that in a bit. And you use predicate to describe conditions for Swift data to filter data. A query applies its predicate to each of the items in the data store. Returning true from a predicate indicates that you want to see the item. So remember, predicate seems complex. It's just a fancy mathematical word to say a function that takes a variable, so an argument as an input, and it returns a Boolean. Nothing more, nothing less. And what's interesting is that you can see that we do this pound predicate. That's because this is actually a macro, and the reason is that we could implement any kind of closure that returns a Boolean, but there would be a problem is that this closure would contain arbitrary code. But the thing is, when you implement a predicate in the database realm, usually, if you do like a contains, for instance, like does the movie title contains this string, or does the movie title start with this string, usually you want a way to translate this into a primitive in your database system. And so what this macro does actually is that it restricts the kind of code that you can write inside the closure. This isn't a closure where you can write arbitrary code. You can only call some very specific functions that the macro will pick up on and will translate into built-in functions for the database world that is hidden for you by Swift data. So it will be very interesting to try and expand this macro once we have written the code to see how the code gets translated. And it also shows why they introduce macro at the same time than Swift data, because without this macro system, you don't have a way to write a predicate where you can write something that looks like closure, but that actually cannot contain any kind of code. If you didn't have this predicate, you would need to have some kind of DSL where you would have this domain-specific language where you have like some kind of enum with all of the possible properties. It would feel less organic, less like regular Swift code. But let's keep moving on. And if what I said didn't make sense, it will make more sense once we have moved on a bit. So yeah, I will explain it just after. But yeah, actually, let's try to see what it does when I expand it. So you can see it returns the predicate of movie, and inside of which you build it, and you have some pre-built predicate expressions, and here it's just one that returns true. So for now, it's just like lifting this true value into this higher order type, but nothing more for now. We'll see, it's probably going to change as we make more changes here. Okay, I was about to see like maybe it's going to change in real time, but no. We will need to do right-click expand to see the result after. Okay, so now what do? We initialize the underscore movies property using the predicate. So something like that. So it's the same movies than the one here. So like that. So I guess, are we going to remove this? I'm not sure, we'll see. They're going to explain why this underscore, so I'm just going to read how they explain it. So this property is created in code that add_query writes behind the scene. So add_query, it's is it a macro or a property wrapper? It's a macro. This one is a macro, and interestingly, the other one is a property wrapper. That's quite interesting. So that also explains why they don't have the exact same color. These two are property wrappers. This one is a macro. That's why they don't have the exact same color actually, because there are two different things according to Swift, and yeah, there are two different things in Swift. So what is this underscore property? It's a property created by the add_query macro. And usually you don't need to interact with it, but making a custom query requires you to access it directly. So add_state, add_bindable, and add_environment work in a similar way to add_query, creating hidden properties. And they're not really hidden because you can access them, so it's not like if they are private properties, but the underscore movies, it's like it's the backing property that actually stores the data. And you can see it as like add_query. it needs to store data somewhere and then add some behavior around this data. And so this is what's happening here. At query, it's this property to store the data and then behavior that goes around it. And when you think about it that way, I think it gets a little bit easier to understand what's happening, but you definitely like win in complexity when you reach this kind of code. And so these properties attach your view to the engine that powers SwiftUI. For instance, the hidden logic in a addState property automatically updates a view whenever the property's value changes. So whenever underscore new movie changes, addState makes sure that SwiftUI knows that it needs to update the UI. And so here we are setting underscore movies manually inside the init. Okay. Step 4, so since we're creating the query directly using its initializer, we can remove the stored parameter from the movie property declaration because it would have been ignored anyway, I guess. Interestingly, you can see, so it's interesting, when you have an argument, it's a macro, but when you don't have an argument, it's still a macro, but like the color changed, you can see. So it's like, I don't know, maybe it's a bug in Xcode actually, but kind of makes you think that maybe the status of this thing in Swift is a bit different depending on whether you pass in an argument or not. Or maybe it's just a bug in Xcode, which could also be possible. But it's interesting to see that happen in real time. Okay, so I remove this. Next step, in the predicate, replace the true value with a Boolean expression that selects the movies to include in the query. So it's going to be title filter is empty or movie title localized standard contains title filter. Let's see what this does. Okay, so it's either the title filter is empty. So if title filter is empty, then so if no filter was set anywhere, then we just return every movie. So if no search, like if the user is not searching right now, every movie should be displayed. Otherwise, you should display the movie only if it contains the title filter, and we use localized standard contains because it's going to take, so you can see it here. This is the most appropriate method for doing user-level string searches, similar to how searches are done generally in the system. The search is local aware, case and diacritic insensitive. The exact list of search options applied may change over time. So it's going to ignore like accents, it's going to ignore uppercase and lowercase. So very useful. So that imagine like the movie is called like Dune and the user types something like that. The user expects to see Dune. Same thing, someone mentioned Amélie Poulain. That's the name of the movie. If I type this, I expect the movie to be displayed. So that's why you use localized standard contains. I think I made a video about this one. I made one about localized standard compare, which is the same logic but for comparisons. And I might have done one about localized standard contains also. I'm not sure. But I think I did one either on this function or on like a related function that allows you to ignore diacritics and things like that. All right, so now let's see actually how this gets expanded. So you can see, if there wasn't the macro, this is what you will need to write by hand to have the same level of type safety in the fact that you are only using allowed operations. So it needs to build. It needs to create a disjunction. So what's a disjunction is just OR. Like in logic, the OR operation, you can also call it a disjunction, and the AND, you can call it a conjunction. So that's nothing but that. And so you can see it's disjunction on the left-hand side. So it's a key path, and then the fact that it's not empty, and or rather that it's empty. On the right-hand side of the OR of the disjunction, it's calling localized standard contains, and then it gives the argument to call it. So what's interesting is that this here under the hood probably get translated into native functions of SQLite, for instance, so that it's easier to run the query, because what's happening is that if you were to pass in an arbitrary query, an arbitrary closure, you have two problems. First problem is, how do you pass in a closure from Swift to whatever database is being used under the hood? And the other problem is that databases are meant to handle very large amount of data. They have strategies to handle queries on that very large amount of data, like indexing, for instance. But how do you leverage indexes when you have a piece of arbitrary code? And here, using this macro solves the two problems. First, because it allows you to have under the hood this DSL where you can match what the user has expressed in Swift into something that can be used by the database system under the hood, and that will be able to use the optimizations of the database system. It's hard to say for a French speaker, like database system. And so that shows the power of macros once again, because you write something that looks like your regular Swift code, and actually it gets parsed and compiled. Like the word compile is not an overstatement here, because what's happening, this macro is a small compiler that compiles this code into this other code, and I'm sure we are very glad we don't have to write this kind of code by hand. So this is very impressive and a good example of how powerful macros can be. Also, try to imagine what the code of this macro must look like. It must be pretty complex, even though I'm sure that there are ways to implement the thing, because you are still, in the end, it comes to like mapping a subset of Swift into this DSL. So when you know how to write it, I'm sure that it's not that complex, in the sense that it's more like, okay, is this an allowed piece of Swift? If yes, then map it into the other language. If not, then return an error. So you can see the big picture logic of how it works, but implementing it, you probably need to know a little bit more about how to handle the abstract syntax tree in Swift. And if you've ever had to write a macro, you know how complex it is. If you haven't and you would like to know how to write a macro, check out my live stream about how to write your first Swift macro, which is also available on my channel. And yeah, I agree that the word impressive can definitely be used here. It's not an overstatement. And do we have access to the code? Actually, no. I don't think so. So I was about to say I don't think so, because it's part of Swift data, but here it seems that predicate is actually part of Foundation and not Swift data. So I'm not sure that you have access to it or not. Foundation is still is not open source though, so I don't think that that you can access it. But I'm not sure actually. You can see an interesting thing is that predicate seems to be codable. So it seems that you can encode a predicate, which is also something that you obviously couldn't do if it was just some arbitrary piece of code. So I'm not sure actually if the macro is open source, but I think a Google search should be able to let you know about it, because if it is, it's probably in one of the GitHub repos of Apple. So either like the Swift repo on GitHub or a similar repo. Okay, let's go back to the tutorial. So step 6. To make sure your filter works, add a third preview and pass a value for the filter. Select the new preview named filtered in the canvas and experiment with different search terms by editing the string in code. So let's do that. So we add a new preview. So at the end of the file, like that. Okay, let's display the previews again. And so here it starts with TR, and we'll see so which movies will match this filter. Oh yes, you can see. And so if we do TRA, it should keep Traveler and Train, but not Trek. Let's try it. You can see it works. And if I do TRE, you can see also that it works. So it's pretty cool. I guess next step will be to add a kind of like a UI to be able to search in the UI and not like in code, which is nice, but yeah, it's going to be hard for the user to edit the code every time they want to search for a different movie. Yes, section 9, I guess the last one. Add the search interface in a wrapper view. So more of a Swift UI part, but a nice way to conclude this chapter, I guess. Now that you have a movie list view that can filter its query, you need an add_state property of type string to let people enter search text. You'll pass the property into the movie list initializer like this. So movie list filter search text. Movie list can't create a new instance of itself, so you'll wrap it in another view that manages the search text and provides the filter interface. Wrapping views like this is a common technique to extract view state that has a cascading effect. Okay, so it's interesting. We're not going to add, I would have thought that we would have, just after the toolbar, added like, because you have this, you have a searchable, modifier, but I guess we're going to add it into a parent view so that maybe we can also apply it easily to the friends list. Maybe we'll see where this leads us. The starting point is that we create a new view called filtered movie list. So let's create a new SwiftUI view, filtered movie list. All right. Step 2, in the views body, we display a movie list. All right, like that. For now, there are no movies. Okay. Then we switch to the movie list file, then remove the enclosing navigation split view. Don't forget to delete the detail closure too. Okay, so we go into movie list. And so we are asked to remove navigation split view and also the detail part, which is here. So I'm going to remove this like that, and then just reindent by doing Control and I. Okay, we are good. Let's check if the project builds. Yes, build successful. Okay. So because the filter list will be the top level view in the tab, you'll move the navigation split view there, and the movie list is no longer inside navigation stack, so all navigation links are disabled for now. To ensure movie list previews continue to have navigation bars, matching the way the view appears in the app, wrap them in navigation stack views. So we're going to wrap each of the previews in a navigation stack. So remember, we can just select the code, open a curly brace like that, same thing here, and same thing right here. Okay. Then in filtered movie list, we add a navigation split view wrapping the movie list. Okay, so let me copy paste the code. So filtered movie list, we add navigation split view. All right, let's put back the preview so that you can see what I'm doing in real time. Okay, perfect. Next, step 6. To view your sample data in the preview, add the appropriate model container, and we also need to import Swift data for that. Okay, like that. So now we should see the data appear. Let me make it a bit smaller so that I don't cover it by mistake. All right. Step 7, add a state property to contain the search text, then pass it into the movie list initializer in the view body. So we add the search text here, and then we pass it into the movie list. We're going to say title filter search text. So actually it's a nice way to do it because this way we don't add the responsibility of doing the search inside the movie list. It's a way to separate responsibilities. The movie list is only focused on displaying a list of movies, and then the search logic is going to be the job of the parent. Or rather, displaying the search UI is the job of the parent view, but the filtering itself is still the responsibility of the child view because this is in the child view that we have implemented the predicate and everything else like that. So here they say, recall how add state properties work. When search text changes, SwiftUI updates filtered movie list in the process, passing the new value into the movie list initializer. In turn, the movie list view creates a custom predicate and query based on that value. So when search text changes, the body is regenerated and movie list is recreated, or maybe just updated. I mean, movie list is recreated with a new title filter, and then the SwiftUI engine can update the part of the UI that need to be updated. And so this is when we do the searchable modifier. So we add a searchable modifier on the movie list and we connect it to the search text property. So this is a really nice API that was added in Swift, I think with iOS 15, this searchable API, which adds a search bar. Lets you add a search bar like automatically. You can see you can just scroll down and the search bar appears, and the text we'll write is connected to the property search text right here, just like this, by adding the $sign. So it's very convenient, very efficient. So really nice API. And so we can search, for instance, difficult cat. I can search for limitless, and I can also search for Trek REK because it's about like contains. We used localized standard contains. Are there other? There is also localized. I was about to look for like a prefix, for instance. You could also say like prefix, or like you could say like has prefix, for instance. And if you do that, oh, you can see it's interesting because has prefix, it's not supported in predicate because I guess it cannot be matched into something in a database world, but you can do starts with. And so starts with like that. This one seems to work actually. So let's see. We need to go into a filtered movie. I'm going to pin it so that we can move to another file and still keep the same preview being displayed. And so here, if I search, so you can see cat won't appear because it's really starting at the beginning. But if I do like amusing, it works. But I guess if I do everything lowercase now, like lowercase L, or if I don't keep the same case, you see if I do like capital I, it won't work anymore. So not a great idea to do this for the UX, but you know that you can use this function if you want, but you cannot use every single function. I see a good question. Is there a list of all of what you are allowed to use in a predicate? There might be one in the docs, I'm not sure. Actually, if you look on my channel, I have a live stream from last year from WWDC, which was called like Let's Explore and Discover Swift Data, and I got stuck exactly here when it was about writing the predicate. I didn't know where to look for the information of what can you do inside the predicate. So Swift Data had literally been released the day before, actually less than 24 hours before. So back then there wasn't, or at least I couldn't find this documentation. Maybe now it's available, but if you find it, please let me know either in the chat or in the comments of the video, because I'm sure it would be a very valuable information. And it's a very good remark. Thank you for making it. And so let's move on to the next step, step 9. In the root content view of the app, replace movie list with filtered movie list. So that when we launch the app in the simulator, we start with the correct view. So here. Or rather, no, it's in the content view. Yeah, I was in the wrong place here because we still want to have the tab view. Okay. Your app is complete. Well done. So if we launch the app in the simulator, it's funny because I thought this would take only 1 hour, and actually it's going to get close to 2 hours. So I'm really glad that last week I was like, okay, maybe let's do this other part another week, because doing like 4 hours of live stream would have been way too much for me. And we have the search. So we can search for Dune. There is only one, I mean, every movie matches Dune, but you can see one, for instance, Q. I'm gonna add the movie, so Amélie, I guess that's the English name, because in French, the name is Le Fabuleux Destin d'Amélie Poulain. So the amazing fate of Amélie Poulain. But it might just be like Amélie or Amélie Poulain for the international name, actually. That makes sense. And trying to make sure, I think it was Julien who gave this. I think it was Amir. Yes, it was Amir who gave this example. So I'm also going to add you to the list, and so I can set that your favorite movie is Amélie Poulain. And let's see if it worked. Yes, it did work. Perfect. And what I wanted to show also is that the search is diacritic insensitive, because I didn't put an accent over the E, and it's still matched with the movie, which does have an accent over the E. So once again, the interest of using functions like localized standard contains or localized standard compare, because they give you a really nice UX. And if you had to implement this behavior yourself, it's harder than it seems, because you need to know about. I know a guy who had to do this once, and he had to learn about a lot of like details of Unicode, and the spec of Unicode is a really big book. So you want to use these functions, and you want to be glad that you have these functions available, because how to implement them is something not fun at all. Not fun at all. You can believe what I've been told. It's secondhand knowledge, but it seemed like credible enough. Okay, so like last time, we have a little quiz and then a wrap-up recap before we finish. So question 1 out of 3. How can you establish a relationship in Swift data from model type A to B? So you add a relationship modifier to the model container, you create a new class C that contains properties for both A and B, and you declare a property in A of type B. So that seems to be the correct one. Yes, it's what we did, and Swift data, through its macros, analyzes each model to find properties that with type matching other model types. Which view lets you select one out of many options ideal for setting the values of a many-to-one relationship? So picker, for each, button, form. It's a picker at the top level, even though you might put a for each inside of the picker in order to iterate over the data. But it's indeed a picker. And last one, which of the following is a true statement about predicates? You can use a predicate to filter certain results in a query. That seems true. A predicate returns false to indicate that the item should be included in the query. No, it's the other way around. And you can use any Swift code in a predicate. No, you can't. Interestingly, this, they didn't highlight it in the tutorial, but that's something that we saw and we covered. A predicate, in the closure of a predicate, you can only use a specific subset of function calls and Swift features even. Also, expressions supported by predicate. I'm going to display it in the live stream. I don't think you can put a link in the chat. I don't think it's allowed, unfortunately. But if you can put, I don't know if you can put a link in the comments. But if you can try, that would be great. Otherwise, if you can send it to me, like either on LinkedIn or on Twitter, and then I will add it myself in a comment, because that would be very useful. I will just like look for it. Actually, you know what? I shouldn't be lazy. I'm just going to. I've made a screenshot of your comments, so it's on my desktop, and I will search for it. So thank you for finding the name. And so it's the first one. You can use a predicate to filter certain results in a query. All right. What's the wrap up? So let's read the wrap up. So wrap up about relationships and queries. So we added a model for friends to our app and created a relationship between the friend and movie models. Creating related models like this lets people create richer app data. We also created a dynamic query to power a search interface. So reflecting on the concepts, relationships. When you plan an app, you'll probably create more than one model type, and those types will probably have relationships to each other. Take managing contacts as an example. Should a person model have properties for street, city, and postal code, or should you create a separate address model? The answer depends on whether you expect people to create more than one address for a contact. As you create a data model for an app, think carefully about how people will want to use it. Also, consider the features you might want to add in the future, which can affect the design of your models today. So if you've ever had classes about designing a database, that might remind you of a few things. Dynamic queries. Swift data is powered by a relational database engine, so I guess it's SQLite, that efficiently stores and retrieves your models. It also gives you powerful queries to filter the retrieved data and sort it for display. You can provide Swift data filtering and sorting criteria when declaring a @query property. But often, you'll want to give people a way to choose how they want to see the data in your app. For example, sorting items alphabetically or by date. To create a dynamic query, you take advantage of a key SwiftUI power, creating small single-purpose view. Though it may feel odd to have a filtered movie list view that just contains a search field and a movie list view, that's exactly the pattern that you should follow. interesting to see Apple give an opinion about architecture because they tend to be very vague about this. Interesting to see them take a stand here. The key is providing a custom view initializer, which lets you initialize the query property wrapper with values passed from the parent view. One thing that's interesting is that if we look at the movie, and I want to highlight it because I think it's important. If we go into the movie list, you can see that we say that it's sorted here by passing a key path. And here, what we do is similar to when we use the predicate, because this is something that Swift Data can translate into using the sorting algorithm of SQLite under the hood. However, if you look in the movie detail view, you can see that here we are sorting inside of Swift. And when you deal with a small amount of data, like it's likely the case here, it's not that much of a problem. But if you were to deal with a large amount of data, you definitely want to sort inside the database and not inside of Swift, because with like 100, 200, 1,000 or more pieces of data, you will see a really, really big difference about it. One of the reasons being that databases, they are optimized to sort in a very efficient way, maybe with avoiding to duplicate data and this kind of thing. So you really want to use this. Like I have memories, so it was from 10 years ago. More than 10 years ago, from 2012, actually, during my second iOS internship, where, if I remember correctly, we had an app that was made for like real estate agents or real estate agency. And so you had a database that would like contain like properties. And there was one thing where the UI of the app would freeze when you would like load the data, and it's because the sorting was made in Objective-C by then, so in iOS code, and it took like between 1 or 2 seconds to do the sorting, and it would block the UI because it was happening on the main thread. And simply by moving the sort into the database, it completely removed the issue because the database was way more efficient at doing the sort than Objective-C was about doing it, because NSRA was probably not super optimized to sort large amounts of data in a minimal amount of time. So back then we were using like the iPhone 4S and the iPhone 4 and the iPhone 3GS. So iPhones and iOS devices are much more powerful today. But it's still worth keeping that in mind, because it can be a big gotcha if you are using if you're dealing with large amount of data. And definitely what you don't want to do is to start like adding complexity to your code by maybe like doing the sort async and adding a loader on the UI, when you can simply solve the issue by doing the sort in a database where it will be much faster. And once again, saying database in French when you're French is much harder than it seems. Okay. And property wrappers. So this is something that you probably know if you know Swift already. Here they are. They are about here they mention it, but it's more like a recap for people who are learning about Swift, but I will still read it. So in this tutorial, you learn that the @state, @query, and @environment annotations create hidden code that connects your views to Swift UI state management. For example, look at this property declaration. So @state private var number of votes. In reality, you've created 3 properties. First, there's a property of type state of int. State is a property wrapper containing the code that links to the value to Swift UI. You can refer to the property wrapper directly in your views body, but there's rarely any need to do so. So you could do underscore number of votes, and then you get the state and not the value inside the state. Next, a commit property with the name of the original property. When you refer to number of votes, you're really interacting with the wrapped value of underscore number of votes. Okay. And finally, a commit property of type binding of int. When you access $number of votes, you're really interacting with a binding that underscore number of votes provides. Binding is yet another property wrapper that links your code to Swift UI. This is quite complex, so if you don't know about this, please check out my videos about learning SwiftUI. They go over this in more details and in less of a rush. So what topic and skills have we covered? Relating one model to another using properties, making many-to-one relationship with an optional model type, making a one-to-many relationship with an array of model types, using a picker to choose a value from a list of options, predicates that use logical expressions to filter data, initializing a custom query property, and using a wrapper value to enable dynamic updates of query criteria. How could you, what could you do if you wanted to keep working on this app to expand your understanding and your knowledge? So you could let people filter the friend list by name, and the logic would be the same than for the movie, so it should be quite accessible. Change the picker style in friend detail view to see what SwiftUI offers. Use the onDelete modifier in the movie detail view to let people edit the list of friends who favorited the movie. Should be also fairly easy. And use a toggle in the toolbar of the filtered movie list to let people select whether to sort the movies by release date or by title. Pass the choice into the movie list initializer and use it to construct the appropriate query using an if-else statement. So that would be quite... this one is slightly harder, but not that much, so quite a good one. I would recommend that you do the fourth one if you want to do one that has that will require you to think a bit more than just copy and pasting code and changing a few things around. And then, if you want to change yourself, so plan birthday gifts, add a gift model type to the birthdays app from a previous chapter. Let people plan as many gift IDs for a friend as they want. So it's basically setting up the same kind of relationship, but by yourself and from scratch. And add a movie cast and crew. Add a third model type that represents a cast or crew member of a movie and give it a many-to-many relationship to movie. In the detail view for the new model, list all movies that have been a part of. In the movie detail, list all participating cast and crew. Update the movie list filtering to include a text search of the cast and crew. For this, you need to add another clause to the predicate using the logical OR operator, so the double pipes, followed by this code, which looks inside an array of related models. So they do movie cast and crew contains, and then inside of it, localized standard contains. So this one is actually quite an interesting one also, if you want to try it, because we haven't done many-to-many relationships, so that could be interesting. And the last one that you could also do is to try and see what happens if here in the friend, in the friend in the model, so like that. If here you add another property like disliked movies, what's going to happen? Will SwiftUI still be able to infer what is the inverse relationship of the in the other way in the movie type? How will it know if it should use the favorite movie or the disliked movie as the inverse? That's something that you can also explore. I was planning to explore it, but it's like 2 hours of live and I'm starting to get a bit tired, so I won't explore it right now. But if you want to explore it, please do it, and feel free to share your findings in the comments. I'm sure that other people will be super interested. And then you have some links to learn more. And I think that's the end of this tutorial on learning the basics of Swift Data. So I really want to give like a huge shout out to people at Apple that made this tutorial, because it was a really well made tutorial. We've learned the basics and we've covered them. We took our time, but we covered them in a way that we have a strong understanding of how Swift Data works, and it took us 4 hours, which I think is like half a day of work, so it makes sense, and it's a good like a ratio, I would say. I see a question. I will answer it very quickly. Hello, where do you see the future of iOS native development? I've answered this question in detail at the end of a previous live stream. You can find the answer. Go to my website, swiftwithvincent.com, and you have an article that is about this, about my opinion about like native versus hybrid development, and you can read it, and it's written much better, and I will be able to phrase it right now, but TLDR, if you're looking to make an app that is state of the art and where the app is the main differentiator for your company, native development is going to be very important for you. I always take the example, I work at Photoroom. The Photoroom app is what makes the company successful, and so the app is native. If you're a company that does something like being able to book like appointments with doctors, for instance, maybe you don't need a native app to be successful, because what you need to be successful is handling, like convincing the doctors to use the solution, making sure that you're compliant with the law, with the like law around medical data, that kind of thing. So the bottom line is that if you think that the app will be a key part of the success of your company or your efforts, then I think native development is very important. And I think that the most successful apps will keep being like native apps. And the only exceptions of successful apps that will not be native will be apps like I was giving the example of booking an appointment with a doctor. It's apps where the innovation isn't in the app itself. Actually, it's in another domain, and the app is just a way to interact with this innovation. And so, just to conclude, I wanted to say so big thank you to everyone who was watching live, who gave some really great comments during the live stream. So thank you, Julien. Thank you, Emir. You give like great remarks, great questions, often mentioning things that I wouldn't have thought myself to mention. So thank you, because your help really helps elevate the quality level of this live stream. And I guess I just have to say, yeah, it's the end. So next week, and I think for the following weeks, I will do the other tutorials, the one about getting started with iOS. So they will be like complete beginner tutorials. So probably if you're already experienced, you won't learn a lot of new things, but I want to have them so that when people want to get started and they start from scratch, I don't yet have content for them on my channel, and I really want to have this content, because this way I can show the basics and then accompany people basically like through all of the steps of their iOS journey. And I really want to have this missing piece of content. So this tutorial from Apple will be perfect for that. So I guess I just say like, yeah, see you next week, this time to learn how to build an iOS app from scratch. And for people who are still watching, well, thank you for having watched, and have a good rest of your day, and see you next time. Bye-bye.